Hello, this is Mr. Waterman, and we are looking at parallel and perpendicular lines. This is the first section of Chapter 3, 3.1. We are going to talk about parallel and perpendicular lines, which you're already familiar with. Today we're also going to learn about skew lines, which are lines that never intersect, but they are also not parallel. For example, in this drawing of a cube, we have this line, line L, that's vertical on the back of the cube, and then on the front of the cube we have this line, and these two lines never intersect. So they're called skew lines. Okay? So write these three definitions down. Parallel lines do not intersect and are coplanar. Skew lines do not intersect and they're not coplanar, so they're not in the same plane. Okay? Two planes that do not intersect are called parallel planes. So write those three definitions down. In this example, lines M and line N, this line and this line, are parallel lines. That's indicated by an arrow on each line, and in shorthand notation you would say M parallel to N. And those are small m and small lowercase m and n. Lines M and K in this diagram are skew lines. So line M and line K will never intersect, but they're not in the same plane, so we call those skew lines. Okay? Planes T and U are parallel planes. So those are planes that do not intersect. So we would indicate that in shorthand with a capital T parallel to a capital U. Plane T parallel to plane U. We have two postulates talking about parallel and perpendicular lines. So if I have line L and a point P not on line L, and I want to draw a line parallel to L, I can draw exactly one line that is parallel through point P. Similarly, the perpendicular postulate says a similar thing, but for parallel lines. So, or for perpendicular lines, excuse me. If I start with line L and point P, and I ask you to draw a line perpendicular to those, there is exactly one line perpendicular to line L that goes through point P, indicated with a right square. All right? On the parallel lines, we indicated on a drawing with arrowheads. Two lines parallel to each other. Go. Next, we're going to talk about angles formed by transversals. First of all, a transversal is a line that cuts through two or more other lines. So in this diagram, this line T is our transversal. So we have four different angle pairs to talk about. Two angles are corresponding angles if they have corresponding positions. So for example, angle 2 and angle 6 are both to the right of the transversal here. They're both on the right side, and they're both above these other two lines. Okay, so 2 and 6 are both above and to the right, so we call them corresponding. Two angles are alternate interior angles if they lie in the interior between the two lines, all right, and are on opposite sides of this transversal T. So 4 and 5 here we would call alternate interior angles. Next, alternate exterior angles. Same kind of idea as the last one. They are on opposite sides of the transversal, so we call that alternate, but they're exterior, so they're on the outside of these two lines. All right? Alternate exterior angles. And lastly, we have consecutive interior angles. These consecutive means they're on the same side of the transversal, so these are both to the left of the transversal, and they're on the interior of these two lines. So let's try and exercise this. So, for example, corresponding angles. On here, identify all pairs of angles that are corresponding. We have 2 and 6 are above and to the left. All right? For question 1, I'd like you to identify another